Algo views here. Today we're going to solve this problem on LeetCode called two sums. It's classified as easy. Let's see what we have here. We're going to do this method similar to what this person has recommended on internet, which is reactor. Repeat the question, write our examples, describe your approaches, write your code, test, and optimization. So first we start with repeat the question. Giving an array of integer nums and integer targets, return the indices of the two numbers such that they add up to targets. Remember, you have to return the indices of two numbers, not the value itself, but indices. Okay, and they sum up. Okay, you might assume that each input word have exactly one solution, and you might not use the same element twice. So basically, we need to go through the list of numbers and have them positioned in the memory such way that they can be reused, but not used more than once. You can return the answer in any order. Okay, that's part of the repeated question. Let's check the examples. So we have example here. Example 1, input nums. We have 2, 7, 11, 15, and the target is 9. So target is 9. What we have here is we have 2 and plus 7 is equal 9. We cannot use 11, we cannot use 15 because they're bigger than 9. And then what we assume here, if we see the constraint, is the numbers could be negative. This is something we need to take into account. And the target could be negative as well. The number length is higher than 2, and then just we can have n elevate power to 4 numbers. Okay, so we need to be careful here with negatives, both for the nums and for the targets. In this case, we do not have negatives here, so if 11 and 15 is bigger than 9, we can discard them directly. So the result from this example 1, the output is 0, which corresponds to the position of 2. And then the output for position 1 is position 1 is number 7, which adds up to 9. Okay, explanation, because num0 plus num1 equal 9 will return 0, 1. Example 2, input nums, we have 3, 2, 4, target equals 6. So we can try add 3 plus 2, add 3 plus 4, 2 plus 4, and 2 plus 4 is the solution because we have 1 and 2. So 1 is corresponding to number 2 and 2 correspond to number 4. Now example 3. Example 3, we have two numbers, they are the same. So we know that number could be repeated. And this is one of the easier question we need to clarify at the beginning. If the number can be repeated, is unique or not. And sometimes along with the question about if the number could be negative or 0 is included. So in this case, the target is 6. We still have the solution 0, 1. That's how you we can write out our examples. Then describe your approach. So a naive approach would be just, we have this number here. Two, 7, 11, 15. So easy approach would be like put each one of the numbers. Add them to the rest of the list. And then check if the result is equal to the target. Now this has two loops. The first loop is for example, we get 2, and then for 2 we are going to loop through. We're adding 7. We add 11. We add 15. And then so this is what you have in the index is another loop. At the same time, for giving number 7, we add 2, we add 11, we add 15. At this point, we cannot discard the numbers because we know that, okay, certainly we can have negative numbers here. So the easier way is just doing the simple algorithm without any kind of optimization. We can always do the optimization later. Okay, plus 15. So we have this number here, and then we have 15 plus 2 plus 7 plus 11. Okay, so this has a complexity of O of n cube, so m squared, because we have two loops here. Basically, first we need to look through each one of the numbers, and by each one of the numbers we need to check if the remaining items, by adding them to the current number, they are equal to target. Okay, we can be a bit smarter here. We can have let's say the structure that will help us. So we can have hash map. So basically, a hash map is a content where you have a list of two items, item 1, item 2, item 3, item 4. They could be equal, they could not be equal, and then we can get items true by accessing from the item 1, get item 4, accessing by item 3. Now, what to store in this hash map? First, we need to pay attention that we are being asked to return the indices of the two numbers. So we're not being asked to return two numbers, but indices of them. So at some time, we need to store the numbers to check if for the targets. We need to add to the memory the index of them. Okay. So an easier way to do it is we can add each one of the items here, like 2 has position 0, 7 has position 1, 11 has position 2, 15 has position 3. Okay, that's our way to do it, because by having this list, we just have to go through the list, and then by building each one of the items, say okay, true, yeah, we check if there's any items from the list we are having add them to equal targets. So in this case 2 and 7, so we need to return 0 and 1. But this is still in a cube if we build this first and then we go through each one of items. We can reduce the complexity of this to O of n by building the hash map at some time while we're checking the numbers. Okay, so the way how to do it is we use something called instead of storing the item itself, we are storing the opposition of the item that we need to reach to the target. So by opposition, I mean if the target in this case equal 9, so instead of storing 2, we're going to store the difference between 9 and 2. So in this case 9 minus 2 is equal to 7. Okay, so by storing the difference, we can use a method that comes from the hash map called contains key. So contains key basically have the complexity of O of 1, time complexity of 1. And with this time complexity of 1, that we can guarantee that each one of the operations that when we're checking the items, we do have, we can reach by O of n, because for each one of the items, we are going to have an O of 1. So that's O of n multiplied by O of 1, which is O of n. Just to illustrate how everything works. So first, from the list that we have, we're going to have let's say hash map is going to be empty. Okay, so we have a list here 2, 7, 11, 15. Now we are going to first item. We check the first item if the hash map contains any of the items, which is not. So what we're going to do is we're going to store the number opposite to the hash map in this case. So we're going to store 9 minus 2 which is 7, and then we're going to store the position of it. Okay, so in this case we have 7 and 0. Now when we go into the second element, we know the position of the second element, and then we know that someone else before was looking for 7. So we ask if any of the item the list were looking for 7. If it's that the case, that we found some number that is exactly matches and add up to the target, so we can return both the position of the item which is here and the position of the item which was stored before. Remember, this is the index of the items. So value we need to find it, and then the index itself. So let's do this. So this step number 4 is write your code. Let's write my code. I'm going to write some steps. Build create a hash map, and then find loops through the list, check one of the items. Okay, let's do step by step. Say we need a map, which let's call it target map. Target map equal new, because we do have inferred the type of here, so we do not need to have add a new type here. Now, but each one of the items through the list, we have a typical for loop. We can use another kind of loop, but in this case, we need each one of the items in the list. So we need the index, and then we need the index as well. So the easier way is num is number length I plus. Okay, so we're going through the list, and the I is our index, and possibly this is the index we need to store, and the index we need to return. So what we need to check is the content of the target map, if it contains any of the items. Say, okay, if the items that someone was looking at is us, okay, someone was looking for the item I, if target map contains key nums I, then we know that we found someone was looking for us, and then we have perfect match in order to reach the target. So we're going to return an array of integer which matches with the content. Return new int. So this is how we build content. So we have I, which is ourselves, and then we need to get the one which the position of the number which was looking for us. Okay, so dot get number 1. Okay, because this is the key. We're using the value of the items that we need to that need to be complementary. Else we are doing target map dot put. If I'm not being searched by someone, so I put some kind of note that I'm looking for someone. Okay, so in this case, for my complementary, we're putting out the values we need. And then the way how to find us, or the position where we are, which is I. Okay. In case we always this shouldn't happen, but in case that this happens, we can always return empty string. So what happened in this case is take 1 and t. They assume that each input will have exactly one solution. So there won't be no solution for this, but for the compilator, we need to return some values. Okay, it's sometimes it's better to return an empty string. We know that there's no values instead of returning a null. Okay, this will be the coding part. Let's go through the statement of number 5, test the code. Okay, we can go through this contents here. Okay, let's test this code. Let's call it test 1. Test 1. Okay, so right now I'm going to use a pointer for the code items. My map is empty. There's nothing we need. Okay, we create a map for items equals 0 from all the items from the list. Map contains key of number 1. Map that we have right now is empty. It does not contain anything. So what we're going to do is we're going to execute this part. Target map put. We're going to put ourselves. Remember, you need to read during the test phase. You need to read the code as such, and then behave as if the compiler is doing this. If we realize something is wrong, we can always write it down. But if we're not following exactly the step that we're doing here, probably we're giving some error on the out test, and then we think everything's right, but maybe not the case. So let's go to hash map. I put in the target minus numbers 1. Target right now is 9. So minus num, this is make it 7. And with the 7, the position right now is getting is 0. So 7, 0. Now we're going to the next element. The next element is I equal 1. And then we are asking for a target map. What do we have in the target map? That target map, and right now I is pointing to 7. Target map, we have the content itself. We're looking for 7. Yes, it found 7 in this case, and then you will return a list of results. So we return the I is equal. So we know that it returns 1, and then target map get number I. So target up is this one. Get number I is 7. So get the content. This is the key. This is the value. Get the content, which is 0. So this will return 1, 0. What happens is in this case, it said you can't return the answer in any order. So it's the same. It's the same value if we're talking about 0, 1 or 1, 0. Okay. Let's do a second example. Make sure that everything it's okay. So test 2. Usually it depends on the time that you have. You can run this or not run this or do more or less test. But on the real interview, you are going to giving a normal editor, and then sometimes you don't need to compile the code. And actually, it's better if you don't compile the code, because you might make some compilation mistakes, and then that make you waste much more time in fixing the error than actually checking and fixing the results. Okay. Okay, test 2. We have the list we have is 3, 2, 4, and then the target we have equals 6. So, and the map we have is empty from beginning. So we start from item 3. Starting from item 3, list empty. We're not doing anything, so we're going to add this 3 and 0. Now we have going to the second element. I equal 1. Sorry, let me come back here. I equal 1. I checking if the list contains 2. And this 3 is because 6 minus 3 is equal 3. Sorry to mention, not mention that. Now 6 minus, we're going to this item 2. There's no 2 on the list of keys. So what we're going to do is we're going to store the opposition, the complementary number of 6 and 2, which is 4. And then say we're in position 1. Now we finish execution. We're going through the loop again. Now I equal 2. I equal 2. We have number 4. Number 4 is contained inside the list, inside the hash map, which is 4. So what this algorithm will do is we return 1 and probably 2 and 1. The order doesn't matter, so I have 1 and 2. This is okay. Test 3. We have target equal 6, so we still have 6 here. The hash map is 3 and 3. So the numbers of 3 and 3, and then we have hash map here. Okay, we start from the first number, list 70, so it's natural that it gets 3 and 0, because 6 minus 3 equals 3, and then we have here. Okay, now we're going to the second element, which is 3 as well. What happened with this 3? You find this 3 over here, and then you say, okay, I found I'm in the complementary of number which is position 0. So what I'm going to return is 1 and 0, which is exactly to result what we need, and 0, 1. Okay, let's run this code to make sure everything's okay. We expect for, okay, semicolon here, kind of font symbol for int equals nums. Again, nums. Okay, nums. Oh, we have nums here. So easier way is looking for nums on the place where we need. Yeah, nums. Yeah, likely a compilator we know we give you better results. A compiler, I mean, or any IDE. But on the test, I know going to write the code inside compiler, so it's normal that we get used to this kind of compilation error. But it's good if you can fix them with the time. Okay, this seems to work. Let's submit this code. Okay, the code is submitted. 1 millisecond. Everything seems to be okay. Okay, as always, I'm going to post the code and GitHub. I post the link below. This is exactly the code I am writing down. So you have all the 3 tests running here in case you want to clone this code and then write your own solution here. So we have 3 simple tests you can run. And I will post the link of this link of this code on the description. And as always, if you want to schedule 1-to-1 with me, I'm going to post the link on below as well. So you can schedule 1-to-1 with me, like 20 minutes, 30 minutes, for any clarification of questions or any other question you want to ask. Have a good day.